Hello everyone, welcome to the episode 2 of the Kickstart VMware Cloud Foundation project series. I'm Satya Shrestha, a senior staff executive solutions architect at VMware, and today I'm joined by my colleague Vincent. And in today's episode, we'll be continuing our discussions about Kubernetes in and on VCF from last episode. Welcome to the show, Vincent. How have you been?
Hey, hi Satya. Thanks for asking. I'm very good.
Excellent, man. I see a lot of good response in our last video. How has been the feedback for you from your customers and our colleagues?
I think it's awesome, right? We got a few hundred views in just a matter of days. Hope that we can create more content and share more with our customers and partners.
Excellent, man. That is the aim. Okay, so before we dive into today's topic, let's quickly review what we have covered in our last episode. Shall we do that?
Yeah, sure.
So we discussed how VMware Cloud Foundation, VCF, enhances the acceleration of advanced workloads, aiding in the infrastructure and application modernization journey for our customers. And we also discussed that VCF really serves as a comprehensive platform that enables our customers to build, run, manage, and secure workloads that are based on either virtual machines or containerized cloud-native applications that we can run on the same VCF clusters. We also explored architecture of TKG clusters. So in here, we are talking about TKGs that is part of VCF. And we discussed various components and foundational elements of the TKG clusters. And on our first episode, Vincent also provided us a live demonstration on how virtual infrastructure administrator can empower application developers to independently deploy Kubernetes-based workloads on VCF clusters using Kubernetes APIs and command line interfaces. If you have missed our last episode, I highly recommend you to go and watch it in our VMware Cloud channel. And moving on, in today's episode, we'll be covering Supervisor cluster in the context of, again, TKGs clusters, which is part of our new VCF offering. We'll examine its pivotal role and significance in managing Kubernetes clusters and Kubernetes workloads within VCF. So Vincent, tell us more about this critical building block that is Supervisor clusters.
Yeah, sure. This is a very critical component in the VCF with TKGs platform, right? So we're going to spend some time talking about the Supervisor cluster. So again, just to recap, we plan to do 7 to 8 kind of topics in this series. So we have covered the overview of Tanzu on VCF, the architectures, what are the building blocks. So for the next few videos, we're going to deep dive into each of these building blocks. So starting off with Supervisor cluster first, okay?
Yes.
Then we will talk about the RV load balancer for TKGs in the subsequent video, okay? So I'm not going to spend too much time on this slide. I'm just going to deep dive on Supervisor cluster today.
Yes, that's the topic for today, Supervisor clusters.
Yeah. Before we go into the Supervisor cluster, because it kind of used the Kubernetes clusters concept in the Supervisor cluster, so I thought it might be worthwhile to talk about Kubernetes clusters architecture first, because there's a lot of similarities that we can find on these two platforms.
Yep.
So first, on Kubernetes clusters, you have the control plane, and then inside the control plane, you have the etcd database, you have the Kube API server, which is handling all the API requests from agents or from the user itself, okay? And of course, you have the scheduler that takes care of scheduling Kubernetes pods, which nodes that it's going to come up with and things like that. And of course, you have the controller manager. On the nodes itself, the Kubernetes nodes itself, you have this agent running, right? So it takes care of taking instruction from the control plane and then schedule on the node itself to be powered on, to be brought down, and things like that. That is kubelet over here.
Yep.
So this control plane and as well as this kubelet, I think these are the core components. I think that's good enough just to understand the context of the Kubernetes clusters and then use it to kind of contrast it with the Supervisor cluster. So in a typical VCF environment, right, if you want to run Kubernetes in VCF environment, most of all these components are actually running in virtual machines, okay?
Mm-hmm.
All right, so now let's take a look at Supervisor cluster. In this case, rather than the Kubernetes node that is actually running the pods or the workloads, we have the hypervisor itself actually is running the workload. So we kind of like make it similar like the Kubernetes node. So in Kubernetes node, we have what you saw earlier on was a kubelet. So in this case, we have the spearlet running in the hypervisor itself. Mm-hmm. So again, the role or the responsibility of the spearlet is very similar like kubelet, which is basically scaling the pods and getting instruction from the supervisor control plane. So in this case, the supervisor control planes, it's very similar like the Kubernetes control plane, right? Mm-hmm. That's API that the consumer can use kubectl to manage, or you can call the API.
Mhm.
And of course, it has a scheduler to schedule the workloads to be run on the hypervisor itself. Right?
Yep.
So as you can see, this is very similar to Kubernetes, and we are basically borrowing the concept of Kubernetes and put it into vSphere or vCenter.
Yeah. So just a quick question here. So ESXi itself will host that peerlet, and let's say if I add a new ESXi host in this VCF implementation, what will happen if I add, let's say, a new ESXi host? Will it automatically have its peerlet built into it? How does that work?
Yes, you will automatically have the peerlet running in it, and then it will start registering. It's registered itself to the supervisor control plane. Okay.
Right.
So in a demo later on, I can actually log into the supervisor control plane, and you can actually see what are the nodes available, right? And it will show up as an additional node if you add in an additional ESXi.
Got it. And the same question back again. Like, let's say now I remove that ESXi host, so all the metadata, everything related to that will be purged as well. Is that right?
That's right.
Okay. So what I understand in this context here in this slide is, so consumer, they are using this supervisor cluster as they would any Kubernetes, right? Because it is Kubernetes compatible version that we are using here. They use kubectl as usual, and then they interact with Kubernetes APIs, and then also do all the Kubernetes operations that they want to do the same way they usually do on any Kubernetes cluster. Is that right?
That's right. So this is really meant for people who are familiar with Kubernetes already, right? We talked about in episode 1,
Yes.
Why we created this is really because we want to improve the experience of infrastructure as code. So,
Yes.
Someone who is familiar with, automating workloads on Kubernetes, they should not have any difficulty in using this platform, right? The supervisor on VCF itself, because basically it's still Kubernetes.
And that's the developer persona we're talking about here. And now, on the other hand, if you're talking about virtual infrastructure administrator who is used to that, click through things and running things graphically, and now they can manage Kubernetes cluster in VCF on a very graphical manner, and they can manage Kubernetes cluster from the same vCenter console as well, right?
You are referring to the
VI.
the VI admin, right? So
Yes.
the way I look at it is the VI admin is still pretty much managing the platform from, because they are used to be managing from SDDC manager, from vCenter, right? We are talking about VCF. I think that will continues to be the way. However, if you look at the apps teams, which is what we're referring here as consumer over here, they are more used to like creating pipelines using CLI and things like that. But we want to keep the way that it interact with the platform the same way as they are used to. So we are keeping, the kubectl and API way of interacting with, the platform, essentially, which is the supervisor control plane, to be the same, right?
Yeah.
So
absolutely. Yep.
Yeah. All right. So let's maybe move on to look at the architecture. Okay. So as you can see over here, right, this is what we call the vSphere with Tanzu architecture. And you can see there's a supervisor clusters over here. Okay. Let's go from bottom to up. So at the bottom over here, what you actually require is basically your VCF platform, right? So you can run vSphere with NSXT data center networking. Okay.
Yep.
And you can have multiple vSphere clusters on your platform. And in this case, we have one supervisor cluster per vSphere cluster. And in each supervisor clusters, you have the control plane nodes, like what I shown earlier, right? You have the supervisor control plane. This is very similar like the Kubernetes nodes, and you can deploy this as virtual machines. And it's a clusters of 3 nodes. So that forms the supervisor clusters. With the supervisor cluster, then you have all these services. So in this case, we have the VM operator. So VM operator, you can use it to create virtual machines. Then you have cluster API. That's basically takes care of the lifecycle and the deployment of TKGs clusters.
Yep.
Okay, so with this supervisor clusters, you can create supervisor namespace. I'll talk a little bit more about the supervisor namespace later on. You can create multiple supervisor namespaces in each supervisor clusters. In each of this supervisor namespace, you can create a combination of different kind of workloads.
Yeah, right.
So if you take a look at this supervisor namespace, it's all virtual machines.
Yes.
And you can have TKGs clusters.
Yes.
So you can have multiple TKGs clusters. They can be in different virtual machine sizes. And they can also be of different versions as well.
Right.
And if you want to upgrade all these clusters, then, cluster API will be engaged, and you can actually, upgrade TKC clusters with the supervisor cluster. Okay.
Yeah.
And you can have a combination of all different kind of workloads in different form factors. Like, so if you take a look at this supervisor namespace, there is virtual machines, there's vSphere pods, there's also TKGs clusters.
Right, right. So namespace can contain any of those different objects there, right? So one thing I want to ask is about that supervisor cluster, the block there, which has, you said that your supervisor cluster control plane node, it is in a highly available manner, 3 nodes.
Yes.
So each nodes will have those VM operator, cluster API, and VMware Tanzu Kubernetes Grid Service. Is that correct understanding?
That's correct. Yes.
Okay, got it.
Yeah. So now let's talk about the supervisor namespace. So this is where actually the VI admin or the vSphere admins, when they interact with the VCF platform, after they create the supervisor clusters, they can create isolation for different purposes, right? Whether it's for different teams or different line of business. So it's very similar to the Kubernetes namespaces in the Kubernetes clusters. However, there are differences as well. Okay. So the way we represent this supervisor namespace in vSphere is you will see it as a kind of the resource pool. And with this resource pool, you can actually put in quotas over there to say it's like there's so much CPU that you can use, there's so much storage that you can use, and things like that. So there is actually a limit over there that a VI admin can actually go and assign. So once this supervisor namespace is created, they can pass it to the application team, or what we refer to as the consumer. Then they can actually go in and create, like what I mentioned in the previous slide, you know, TKGs clusters, virtual machines, different storages that they want to use as well. So the way how we actually dish out the namespaces, the supervisor namespaces, you could use it for different environments. For example, testing, staging, production. You can create different namespaces for them, or you can actually use them for different applications, right? So different applications, they have different workload requirements. For example, you know, application A requires TKGs clusters, you know, VMs and things like that. So they can actually go and create all these different workload form factors in the namespace itself. And then other applications might have different requirements. You can create a namespace for them so that you can provide isolation.
Exactly. And it's very flexible, like you said. You use either on the same application, maybe the application may want some virtual machines in it, some Kubernetes pods. You mix and match whatever you need, whatever is the requirement for that application, right? So very agile and very, very flexible.
Yeah, correct. So as you can see, like in application A over here, you know, maybe the web app, it's, you know, in microservices, in containers. So you actually requires a TKGs cluster for it. However, you know, there will still be some virtual machines that's required for database tier. So, you know, there could be Postgres or whatever, right? So that can be in virtual machines form factor.
Exactly. For persistent data, just use databases as a VM rather than container and store those data from those Kubernetes pods, right? Yeah, I like that.
Yep. So this is some of the new enhancement in vSphere 8.0 that you can find. If you have experience in deploying supervisor cluster before, you know that if you look through the wizards, there's multiple steps involved, and you really have to, you know, fill in quite a fair bit of things, which I'm going to show you in the demo later on. I particularly like this feature a lot, where before you start the deployment, after you're filling up all the configuration details, you can actually export this config, and it will be shown as a JSON file. So you can actually, and then, you know, maybe you make a mistake, you know, you need to edit something, right? So you can actually go in there and, you know, open up with Visual Studio Code and start editing and then save it. And the next time you want to deploy the supervisor clusters, you just import the JSON file. You do not need to fill in all the things again. It could fail the first time for whatever reason, and you can just import the existing config again.
So it's like a golden config file. You just save it, and you want to be identical, same config on all the supervisor cluster. You just import it, and then just, man, you are ready to go, right? Yeah.
And, you know, I also start seeing customers deploying vSphere clusters, even like in racks, right? So you have like, you know, maybe 20, 30 racks, and, you know, maybe they want to enable supervisor clusters in this 20, 30 racks, and each rack is a vSphere cluster. And like what I mentioned before, you know, each vSphere cluster, you have to have its own supervisor cluster. So you have to keep on deploying all these supervisor clusters in all your workloads. So this will become very handy. You can just export, and basically you can clone one supervisor clusters from one vSphere cluster to another cluster.
Nice. This is definitely a time saver, 100%.
Yeah, so this is how it looks like, right? It's not very long. You can just open up and just edit it and then save it, and effectively just import it the next time you want to use it.
Very handy.
All right, let's move on, and just to continue our conversation on, you know, there's multiple control plane, right? There's multiple nodes inside there, 3 nodes. And I would say, is it highly available? Yes, it's highly available. But then again, you actually need an external component to load balance this traffic into this control plane, right? So usually we use a load balancer.
Yes.
And just like in Kubernetes, right, they don't provide you with this load balancer to load balance the control plane. Similarly, over here, the supervisor control plane, we do not provide the load balancer as well. However, in VCF, we do have options to have that load balancer as part of the platform itself. But anyway, that's beside the point. So, the use of the load balancer is basically to make the control plane highly available, as well as to redirect the traffic when one of the control plane has failed, right?
Yeah.
So, and of course, provide load balancing to all the control plane nodes as well.
Yeah, I was about to ask that load balancer construct there. How is this implemented in VCF?
Yeah, so I'll have a slide later on to talk about this.
Okay.
So control plane needs load balancer, and you have a virtual IP, and then you can actually connect to the control plane.
Yeah.
Then when you create, like, whether is it vSphere pods or TKGs, you actually need load balancer as well, because you have multiple replica of the Kubernetes pods, and you actually need a load balancer. So similarly, it's the same. If the pods goes down, you can actually send the traffic to the working pods. All right, let's take a look at, since we need a load balancer, what are the options available? So if, like in vSphere with Tanzu, you actually have the options of, deploying just using vSphere networking. And with that, then, the NSX LB is not available for you to use. So if essentially what you will have to use is the HA proxy. So we provide that, but it is open source. If you want to test things out and things like that, it's okay to use a HA proxy. It's good for your home labs. You want to do POC, I think that's fine. You can use HA proxy. If you're talking about production setup over here, then with the VCF platform, then you have kind of two options over here. So one is using the NSX Advanced Load Balancer, or commonly known as RV solution. So same thing, you just deploy, there's a controller, the controller clusters, and then you can with the latest release of vSphere 8.0 U2, you can actually integrate it with NSX Advanced Load Balancer or VCF networking, right? So you can start using the NSX ALB already. With that, you can also use it as a ingress controller for TKGs. That's NSX ALB.
Yeah.
You also have the third option where you use the native NSX. Okay, so in NSXT, it comes with a load balancer. You can still use that as well. Yeah, I think if you're talking about production setup, especially for our customers or partners, either the RV or the NSX native load balancer.
Right. So does that mean that even before we deploy this supervisor cluster, the components of it, we need to have a load balancer deployed there in vSphere?
Yes, you need to have the load balancer deployed first. All these different options you need to have. When I show you the demo, you'll see that, like, for example, the NSX one, is really integrated already. So you start deploying the supervisor clusters, the load balancer bring up is automatic for you, right? Similarly for the NSX ALB as well. Once the only thing you need to do is to make sure that you deploy the control cluster and then the RV controllers, and then we'll integrate it with NSX Key Manager. So once that is done, when you bring up the supervisor clusters, the load balancer is already there for you to use. Yeah.
Now, talking about the NSX, because VCF has NSX inbuilt, if a person or our customer, you want to use just the NSX, will that load balancer be automatically deployed there in NSX, or do they have to manually go and deploy load balancer in NSX?
It will be there already in NSX.
Okay, so that would be the easiest way to
consume
it. Yeah, got it. Okay.
All right, so let's take a look at the demo.
Absolutely, man. Excited for it.
As you can see, I'm in the SDDC manager. So you can see this is the dashboard, okay? And of course, I have my workload domains deployed. And I'm going to deploy the workload management. So in SDDC manager, there's actually a workflow. You can actually deploy the supervisor cluster, or what we call it as workload management, from the SDDC manager itself. So I can click on deploy. So like in SDDC manager, they actually present you with what are the prerequisites that you actually need to have. The motivation behind all this prerequisite is to make sure that, when you start deploying, it will be successful, right? So these are all the checklists that the SDDC manager actually go and check and make sure that you have all these things. For example, you need to have your licensing, okay? You need to have a workload domain.
Yeah.
Okay, so whether you are using the management workload domain or DI workload domain, you need to make sure that you have a workload domain. You need to make sure that you have NSX H clusters. So if you're using NSX, you need to have an NSX H cluster. It takes a while to create the H cluster. So, before this demo, I already created this.
Right.
And yeah, networking is important as well. So you need to make sure that you have, /22 subnet for port networking, services IP, and you need to have two routable subnet, so ingress and egress, and they
Right.
might be a minimum of /27. So all this I already have created, and I make sure that I have these routes are routable into the edges. When I create supervisor clusters, all these are already configured for me.
Okay.
And then last but not least, you need to have a content library. And yeah, you can click on here, it will open up vCenter and you can go and actually create a content library. So once that's done, now this is where you have to choose your workload domain and choose your clusters where you want to deploy these supervisor clusters.
Yep.
Like what I mentioned previously, you can only create one supervisor cluster per VCF cluster. So I only have one cluster in my demo here over here, my setup over here. So I'm going to choose that. So SVC Manager now will go and check all the different configuration and to make sure that I can actually deploy a supervisor cluster. So you can see that it's actually checking now. Yeah. So so the vCenter server validation is successful. The network as well is successful. All right, so it's all successful.
Yep. Can we expand those vCenter server validation?
Yeah, sure.
Yep.
I just want to see what is that? Why are they checking? Right.
Yeah. Right.
So, vCenter objects and then NSX detail.
Yep.
And workload clusters. Okay, so yeah, all this checks out. I mean, if you look at the VCF platform itself, PMs actually mentioned this. It's like why is it successful? Is because you kind of pre-plan everything already. You put into a spreadsheet, you generate the JSON file. So a very similar concept, like what I mentioned before. There's a lot of things you need to fill up, and there's a lot of components here, the different building blocks and all of this kind of here. And this kind of like streamline the chances for errors to be kind of reduced, right? Minimum, right? So once a lot of validation over here to make sure that you have a successful deployment later on. Yeah. Right? So all the validation is checked. So you can see that all the they kind of pre-populate some of the configuration as well so that you do not need to key in again in supervisor creation. Right. So the rest of the steps you need to log into vCenter to create this. Okay. Yeah. So as you can see over here, it jumps straight you into the workload management in vSphere. Yes. Okay. And like what I mentioned, you can actually choose two networking stack, whether you want it to be NSX or VDS. Yep. Okay. Like I mentioned before, you actually need the load balancer, right? So if you use a VDS, you say that, hey, you actually need to have a load balancer, whether it's a HA proxy or you need to set up NSX ALB outside this workflow, right? But if you chose NSX, you don't have to worry about the load balancer. So you can have the option of using NSX ALB or the native load balancer in NSX. Okay. Makes sense. Yeah. Then you see there's multiple options over here, right? So what I'm going to do is, I already have a JSON file that I already created. Yeah. So I'm just going to import it. As you can see, it's going to save me a lot of time. It's already have all the options being filled out, like for example, the supervisor name and clusters, okay, storage as well. So these are the policies, what storage you want to be used, okay? And then you have the management network. So these are the management network that you want to use from your supervisor. Yes. Okay, so choose the network, the port group that you want to have, put in the starting IP. So you'll consume 4 IPs from here, right? 3 for the supervisor and 1 virtual IP. Then you have the subnet mask, the gateway, right? All this and NTP. Yeah, NTP is very important. Okay, you need to make sure that you have NTP configured. And then choose the VDS setup and select your edge clusters, put in your DNS IP, which tier 0 you want to use. You can use a net mode. So net mode is enabled by default. You can also turn off it if you want to be in the routable mode. Okay. Right. And the 4, in the prerequisite, they told you that they actually need 4 networks. These are all the networks over here, right? So the port networking, subnet, services, and these 2 needs to be routable. Right? So I make sure that these 2 are routable and they have to be a minimum of /27. Okay. Yes. And you have already provision these ones in NSX, as a different segments. Yes, not in. I mean, there's no need for you to create as different segments in NSX. These are routable, so you just need to make sure that you have BGP configured, static route, and these networks are routed into NSX itself. So that from the external world, when you want to connect to your control plane or whether you want to control to your workloads, connect your workloads, they will actually use all these subnets over here. Yeah, and all those busy routing tables, yes. So once again on that segment, right? So the segment that we have shown there, is it going to be created after we finish this widget or has it already been created? You have to create all this beforehand, right? Yes. Already configured in, outside your network and make sure that it's routable. Yes. There's no need for you to configure anything in NSX at all. right? Okay. And what NSX will do is when they create the supervisor control plane, they will actually consume all this IP address that you have defined over here, right? So when the supervisor control plane has been created, they will take one IP in the ingress and then use it for the supervisor control plane. Okay. You can have different t-shirt sizes for your control plane. So just this is more of a sizing exercise. So depending on how many TKGs clusters you have and how many vSphere ports you want to create and things like that, you have to select different sizes. So I'm just going with the small, right? So a very small environment. But this is the checkbox. If you click on this and you click on finish, you will actually export all your configuration that you have filled in into a JSON file. And then when you click finish, it will start, connecting to vCenters and your control plane will be created. So I'm just going to skip this step because it's going to take a while, right? Depending on your environment and things like that. Some environment I saw that it can take about 20 minutes, some takes about 30, 40 minutes, right? Depending on the resources that you have. I already have another setup that's ready. So I'm going to switch over to the other setup and then show you a little bit more on the supervisor control plane. Okay?
Sure.
As I mentioned, it will take some time for the supervisor control plane to be created, right? So this cluster with the supervisor control plane being created already. You can see over here, there's 3 supervisor control plane, right? And then in my setup, I actually have NSX, right? So there's NSX ages. Then I have the service engine, the RV service engine.
That's a load balancer.
Correct. So as you can see, there's multiple replica of it. So you actually need a load balancer. So see over here, right? This is the virtual service. So this is for the control plane. And see over here, this is an RV. Okay. Yeah, so why is it orange color? Because I just brought up the system. Anyway, it's okay. You can see that the virtual IPs of the system, right? So this actually grabs from the ingress pool. Okay. That they specify 10.20.8.2. All right. So then now I'm going to log into the supervisor control plane. So let me log into the cluster. Okay. And so as you can see that, so basically, I just put in the script how I log on and change the context to the supervisor control cluster. And then you can see that the nodes itself, like I mentioned, this is the supervisor control plane VM. Okay? And the EXXI is the one, the hypervisor. These are the hypervisor. That's where you have, Spearlet running, and they are actually connecting into the control plane. Right. So you can see that I'm actually using kubectl commands, right? So that was a shortcut for me. kubectl nodes, right? So I can see what are all the Kubernetes nodes. So since I'm in the supervisor cluster already, so I'm going to kubectl get ports -a. You can see that in the multiple namespaces. Right. So these are all the services that's running in the supervisor control plane, right? So you have kube system, like core DNS. These are very typical Kubernetes control plane services like etcd, kube API, kube proxy. All these are
they are the default Kubernetes pods, right? System pods.
Then of course we have some custom ones like AKO, which is the RV Kubernetes operator. We have cert manager, for storage, right? So you have the cluster API. You can see over here. These are the cluster API ones. And let me show you the NSX one. So this is the NSX one plugin. So this is actually talking to the NSXT manager, creating getting the ports, the MAC address, everything. It's all through this NSX manager, right? So it actually talks to NSX manager for you, right? So this, you can see that the supervisor control plane does quite a fair bit of things, right? So some of the infrastructure stuff, some of the spinning out of VMs and things like that. Correct?
Excellent.
That's about it. I think that's what I wanted to show a little bit about the creation of the control plane, right? And show you what's running inside the supervisor control plane.
So now in this implementation, you said that we used RV load balancer for load balancing this control plane, right? Can you show us a little bit around that?
Sure. So this is the RV controller. I have shown you the virtual service, but I think if you want to deep dive a little bit more on the RV, right? I think this is a very interesting solution. Provides a lot of automation and helps you with the load balancing, for the supervisor control plane as well as for vSphere ports and for TKGs clusters. Why not we talk a little bit more in the next video?
Absolutely. I think we have the whole module to cover next video, right? Probably that's the right time to do it. This section itself deserves its own video. So absolutely, let's do that.
Sure. So looking forward to the next video again, the next episode, and it will be on RV.
Really awesome demo today, Vincent. Really cool. We learned how the supervisor cluster is built and how it looks like. Really good, man. So then let's wrap up this episode here. Like we said earlier, We'll be covering load balancers, another critical component of any Kubernetes cluster, in our next video. And again, thanks, Vincent, for your time. Really appreciate it, man.
Thank you, Satya.
And thank you, everyone, for staying till the end with us. And we look forward to seeing you in the next episode. And bye, everyone.
Bye.
Bye.